Live streaming is on.
Yep. Hello, everybody. Thank you for joining in. So this is the third CNCF UAE Meetup. We have two sessions today, one by Masa and Youssef, followed by Rutivik and Rushil. Masa and Youssef would be covering on, how to secure your microservice applications on Red Hat Openshift. Rushil will be touching upon how do you run machine learning workloads on Kubernetes. We're live streaming this meetup as well. The details have been published. Go check it out. And there's a meetup group that you can join in. It's called the CNCF UAE Official Cloud Data Computing Foundation UAE group in the meetup channel, the meetup website. You could also go look up the official cloud native list of meetups and look for Dubai region and you'll find us. I think we'd start with like a quick round of introduction of Masa and Youssef, and then we can start with the session. Masa?
Yeah. Hi, everyone. Thank you for joining us today. And my name is Masa and I'm a developer advocate at IBM. I'm focusing on microservices. So I usually work with OpenShift and Kubernetes and explore different aspects of the technology and deliver workshops and write content and tutorials on the topic. I'm so happy to be here today, delivering today the talk about, different routes on OpenShift. Now, Youssef, would you like to introduce yourself?
Yes, thank you, Masa. So, good morning, everyone. My name is Youssef. I am a developer advocate from IBM. I've been at IBM for almost a year and a half now. I mainly work on machine learning and microservices, and I've been enjoying exploring OpenShift as far as I've been seeing lots of things nowadays. I'm really excited to be here with you guys today, and I'm looking forward to today's event. Thank you.
Perfect. I guess if anybody has questions, you could put up in the chat, and I'll keep an eye out for it, and we'll address those questions in the FAQ after session. And yeah, let's get started.
Okay, so I'll start with sharing my screen today.
All right.
Okay, so just a minute. Okay, is it clear now?
Yes, it is.
All right, awesome. So again, good morning, everyone. Today we'll be talking about securing routes for your microservices on Red Hat Openshift, and we will talk more in details about what kind of issues that have resulted in securing the routes for microservices on in general. So before we get started, we would like to share some links with you guys. So we have the link for the tutorial. We'll paste it in the chat. So you will need your own Red Hat OpenShift cluster today to be able to follow up with this in the hands-on workshop. So there's the URL and there's the key. We will also be sharing with you in the chat. So before to access your OpenShift cluster, you would need to sign up for IBM Cloud account, which you can access through this link. I'll be pasting it.
Okay.
All right. So we will get back to it, but for the Handson Lab, you would need the account and the OpenShift cluster. So we will also share a survey link with you guys at the end. So let us talk a bit about the agenda that we have today. So we will start with discussing security microservices and what are some of the issues with exposing applications in general. and we'll discuss the different types of routes on Red Hat OpenShift. And then lastly, we'll discuss, how to secure these routes. So let us start with, the concept of security in general. So when you're exposing an application to, external clients, there's the concern regarding, how secure are microservices. So before that, in monolithic settings, you would have the front end, back end, database, all that bundled in one set, and it's on your server. So whenever you talk about the security in general, you would address it as one piece. You don't discuss like different aspects separately. So when it comes to microservices, you have your application. It's loosely coupled. So you have a database. You could have different security measurements, and then you could have the backend with different security measurements and so forth. So should that stop you from migrating to microservices? No. So just as there are challenges in monolithic settings in terms of security, there are also challenges in the microservices as well, but they are not as hard or tedious to address. So having that said, let us take a look at some of the security concerns in microservices. First off, we have data management. So let's say someone conducts a man-in-the-middle attack, or the connection between the application and the client is not secure. So in that case, first off, we would have an issue with data management, because somebody could be spoofing packets or phishing, and the data that the client is sending to the application is not it's not the same thing. It's not the same data that the client is sending. So somebody is messing with the data packets that is being sent through the network. So this is one issue with the data management. Secondly, we have the API vulnerability. So in microservices, sooner or later when you deploy an application, you're going to have to expose it to the public. So when it comes to the API, somebody could be trying to conduct an attack to either take down a service or basically mess up with the networking of the microservice in general. So this is another issue with it could be a security concern in microservices, which is that when you expose your API, it could be vulnerable to different types of attacks, whether it gets taken down or somebody is just trying to mess up with the microservice here. Lastly, we have the request authentication. So let's say someone's trying to gain admin credentials, admin access on an application. So in this case, somebody could be there are protocols that you could inject within the application, and it could allow your admin access. So in that regard, there has to be an authentication of the client and the kind of request that is being sent to the microservice. So these are some of the top security concerns in microservices. So having that said, this is why you should, it should be taken into consideration what kind of route is deployed onto the application. So let us take a look at the different types of routes. So we have simple, edge, pass-through, and the re-encrypt. These are the 4 different types of routes on Red Hat OpenShift. Now, let us take a closer look at how does routing work in general. So first off, we have the client who is sending a request to the application. So in a production setting, you would have a URL of your company or the name of the application in general. So if it's facebook.com, Instagram, and so on, you would have this link. Otherwise, if it's still under development, you would have it's name of the application, the cluster, and so on. So what happens here is that the client sends the request to the router service. Now, when we look here, this is inside the cluster of Red Hat OpenShift. Now, we have this router service, and it checks which router should it send this request to. So, if we have multiple if we have the same application deployed in multiple zones or multiple regions, this is basically what happens there. So the thing here is that the router service sends the request to the router, and accordingly, the router checks which pod is available to serve that request. So it would send, let's say we have the same application replicated many times. So in that case, the router is gonna send that request to the pods, and accordingly, upon availability of the pod, it's gonna respond back to the router, and that response goes back to the router service, and it goes back to, again, the client. Whether it's it's a 404 or 200 or any kind of request, it gets sent back again. So let us take a look at the first route, the simple one. So this is, this kind of route is very easy to set up, and it's very, straightforward. So you have a direct connection from the client to the application. So again, when we talk about the router here, it refers to the router inside the Red Hat Openshift cluster. So in this case, the entire connection uses HTTP. So this connection from the client to the router and to the application is insecure. Now, this is very, inconvenient, because in this kind of routing, you are vulnerable to a man-in-the-middle attack. So what happens in a man-in-the-middle attack here is that, instead of having a connection from the client to the router, what happens here is that this connection gets, this session gets terminated, and there's somebody who is, messing with, your data. So let's say somebody is, conducting the attack here, and instead of having the connection from the client to the router, there's somebody in the middle here who is, either spoofing or, just messing up with, the data that you're sending. So if you're sending sensitive information such as, username, password, or, your credit card information, this kind of route is not very convenient, and it actually puts you at risk. So having that said, this is what leads us to using different secure routes. So let us look at the first one. So we have what is called edge routing. So in edge routing, it requires, a TLS or SSL layer from the client to the router. Now, so basically, it requires an HTTPS connection. Now, what happens here is that from the client side, the connection is totally encrypted. So again, from the client to the router, there's an HTTPS connection, and we have the certificate authority certificates set up on the router. So to check that this is a legitimate host, and the certificates are genuine, they're set up on the router. So everything is checked on the router's side, not on the applications. So having that said, what happens in the edge routing is that after the connection from the client, after the connection from the client to the router, from the router to the application uses HTTP. So the router does not encrypt the connection from the router from the router to the application. So what this means is that if there's an attack on the internal network of the cluster, there's a chance that your data could be jeopardized. So this is what the edge routing looks like. Now, let us look at the pass-through routing. Now, pass-through routing encrypts the entire connection. So what happens here is that the certificates that we had, here on the router, go to the application. So we have the TLS layer set up on the application as well, and the entire connection from the client to the router and from the router to the application are set up with the same TLS or SSL layers, connection. So what happens here is that your application needs to support the TLS layer, and you need to have the certificates set up there. Because if the certificates are not valid, the router tells you that the application you're trying to access is not genuine, and it's not the same as the one we have. So the router checks if the name of the application matches the ones in the matches the name in the certificates. So if that's not the case, then the router is gonna basically tell you that this is not valid, and you're gonna get that there's an SSL error. basically. So let us look at the Reencrypt routing. So in the Reencrypt, as the name implies, the connection from the client gets re-encrypted. So we have one TLS connection from the client to the router, and from the router to the application, we have another TLS connection. So this adds more security layers to the connection itself. So we have two certificates set up here. So we have one set up on the router and one set up in the application. So what happens here is that again, there's one secure connection from the client to the router, and that same connection is re-encrypted to use the certificate from the application. So what happens here is that the router uses health checks to determine the authenticity of the host. So let's say you establish a connection from the client establishes a connection from to the router, and the certificates are legitimate, and they tell you that they determine that the certificate on the router is legitimate and it represents the authenticity of the cluster. In this case, this is okay and it's acceptable. However, let's say the certificate on the application is not valid. What will happen here is that you will get that the connection is secure, but your application is unavailable. This is because the certificate on the application is not approved of by the router. So in this case, you will get the applications unavailable, but you will get that the connection is secure. So this means your certificate on the router is set up correctly. However, on the application, it is not. So you would have to check that your application uses the same certificate, or it uses a properly signed certificate. So let us look at how the configuration of the certificates work. So we have different certificate providers. So we can either use a self-signed certificate. This is usually done through a tool called OpenSSL. This is very easy, and it's pretty straightforward to set up. So it basically says that you're signing your own certificate, as the name implies, self-signed. We also have supplied certificate authorities. Whether it's R3, such as R3. We also have organizations such as Let's Encrypt and HashiCorp Vault. You can request certificates from there to your application or to your domain in general. So what happens here is that the cluster admin sets up, configures a certificate or one or more certificates from the providers, and these certificates are put on what is called Certificate Manager Controller. This is something internal within Red Hat Openshift. Don't worry about the terminology here, basically. But it's a controller, and what it does is that it creates a secret. A secret is basically something you can store confidential information, and whether it's a password, login credentials, and so on. In our case, we're storing the key and the certificate. And what happens here is that the developers request, the certificate, and the certificate manager controller is watching for these requests. And accordingly, it creates the secret that is accessible for the developers to use within the application. So just to recap on this part specifically, the cluster admin sets up, one or more certificate providers and different certificates, and they are set in the certificate manager controller. Now, what happens is that the developer creates a request for a certificate, and which the certificate manager controller is keeping an eye on, and accordingly, it creates the secret that the developers can use to access the certificate and the key for whatever providers they're using. Now, with all that said, we will be moving on to the Handson Lab to demonstrate these different types of routes. So my colleague Masa will be walking you through the Handson Lab today. So Masa, the stage is all yours. Thank you.
Thank you, Youssef. So I'll be sharing my screen now. Okay. So in the Handson Lab, we will be like demonstrating the routes that Youssef has explained before. And I have shared in the chat the link to the Gitbook. You can find all of the information and the resources you're going to need in the prerequisite sections for the Gitbook. Now, as we mentioned earlier, we have 4 types of routes. I'll be actually demonstrating 3 types of routes, which are clear, edge, and pass-through. I still have to work on Reencrypt, maybe at some other time. As you mentioned earlier, just a quick summary that the clear route is unencrypted. There is no certification, and there is no security with this type of route. And then you have the edge route. It is secured on the on the router layer, but not on the application layer. As for the re-encrypt, it is re-encrypted twice. So once it is re-encrypted on the router level, then it is encrypted again, and then it is re-encrypted on the application level. And the last type, which is the pass-through route, which is encrypted on the application level. So it is not really encrypted inside, like on the router level, you can say. So like the decryption is happening at the application level. Now, moving on to the prerequisites, we have created like Red Hat Openshift clusters, so you can use them on IBM Cloud. It's specifically for the event. So you can access it through this link. You can find it in the Gitbook. And you can also use the link to create your IBM Cloud account.
Masa, just sorry for interrupting.
Yeah, no worries.
Just confirming if everybody can see the screen. Can you, if others can see the screen? Oh, okay.
Can you see it?
Yeah, I think.
Yeah.
I think Rushil had a trouble. He will rejoin.
Yeah, I think Rushil had a. Yeah. Okay.
Is there like an issue or something?
No, I think it's just for one person. He will rejoin. Carry on.
Oh, okay, because I was hearing some weird sound.
Oh.
Okay. So yeah, and if you do not have like OpenShift CLI, you can use it from the Cloud Shell and like without installing it on your machine, in case if you don't have it. Now let's get started. Now, yeah, if you actually go into this link, in case if you want to access your cluster, just make sure to provide with the OS lab key and then your IBM ID that you have registered with, and then you will be redirected to a page that will tell you to go to the cloud. So once you go to the cloud, you will see a list of resources. So if I just go back a bit here, make sure that you are in the Advo work account, and your cluster will be named in this kind of like format, OC secure, and then the ID of it. And so just click on it. It will be like the only service available for you in this account. So you will find all of the information that you're going to need for your cluster, like a cluster ID, the version, when it was created, the ingress subdomain, and much more details. We will be using some of these details in a bit. Now, first thing we need is to access the cluster because we want to log in to OpenShift through the CLI. So just go to OpenShift cluster and click on the top right and copy login command, and then copy the token and paste it in your Cloud Shell. So I actually already logged in here, so I don't really need to perform this step. Next thing, yeah, by the way, we'll also be using a little bit of IBM Cloud CLI because I want to demonstrate also how you can extract information about your cluster, which can be useful in the later steps. So first of all, we're going to create the project, which is going to be, it can be any name actually, but I'm going to name it my route project, for example. Now, next thing is like I showed you earlier, we're going to showcase some of the information about the cluster. Now it's in the setting up step. And the thing is that you're going to need to go to your IBM Cloud account and click on the top right here and log into CLI and API. Make sure that you're in the AdvoWork account because you're going to be logging into that account from the shell. So paste the command. And you can pick like whatever region if you want, or even skip it, it's fine. And then you might also need to like target the default group. Like maybe, for example, here this is the resource group. We're going to target it to access the service itself. So it's going to be IBM Cloud target S3, and then the name of the resource group, which is default. Okay, so in that case, maybe we don't really need it at the moment. So let's give it a try. Now, in this command, which is IBM Cloud OC NLB DNS, in this one, we're going to extract information about our cluster, like the name and so on. You can get the name of the cluster and paste it, or get the cluster ID and just paste it here. Just make sure to replace the parameters, the value of it. Oh yeah, I have to get the resource group then.
Masa, sorry to interrupt, but you're missing an R in the cluster. So.
Oh yeah, I am. Okay. No, I wanted to show it in from IBM Cloud, but we can view the same information at later steps if this one does not work. Let me try again. This one. Okay, I think it's related to this account. Like I can use it with my personal account, but it's okay. Anyways, now in this one, I'm going to show it here actually. It's not really appearing. Okay, so when you actually use this command, you can view like information about the host name, the IP address of it, like the SSL certificate status, and the SSL certificate secret name, and where the secret is actually saved. And it is saved in the OpenShift ingress, which we're going to be using in our next steps to get this. We're going to be using the certificate to create our secured routes. You can use like the default certificate, or or create your own certificate if you have your own domain, for example. But we can use the default one that is meant to be used for securing your routes on OpenShift. Now, in this code lab, we will be demonstrating. We'll be creating two applications. The first one is a simple guestbook deployment, and we can just create it using a secret deployment, and then we're using the image, which is guestbook version 2. So you can just copy the command and in your command line and just create the application. And the next thing is we want to review the information about our pods. So as you can see, it is in running state right now. So it has been created successfully. Next thing is we have created the deployment, but we want to access the the application like inside the cluster, because we don't have a service, and we need a service to create a route, and that's why we're going to go with OC expose deployment, and then we're going to specify the port, which is a 3000 in our case. So if you use OC get service, you'll see it. You'll see information about your service and the IP address and like the ports and so on. So next thing is we're going to just expose the route like in an insecure way. We're going to see how it's going to look like. I bet many of you are actually familiar with it, but let's take a look at it. So OC expose service, my guest book. And then we're going to use OC get routes to access it. And as you can see, this is the application, and you will notice that it is shown that it is not secure because there is no certificate. And this is not a really ideal situation for your, in a production application, especially if you have really sensitive information that will be used inside this page, for example. So, and how we can do that is by, using different types of routes. For example, we're going to, you do it, for example, with this application, using the, what is it called, the edge route. So first thing is we're going to need to extract the secret. Because like I mentioned earlier, we're using the default SSL certificate, and it is actually in the OpenShift Ingress project. If you use OC get secrets, you will find like the name of it is like name of your cluster and then followed by an ID, which is usually your subdomain, you can say, because like you'll notice that it is kind of the same name. And it is of type like Kubernetes.io TLS. There are several TLS certificates and secrets inside OpenShift cluster that are created by default, but each one of them has different uses. For example, some of them you cannot use externally, but this one we can use it. Oh, yeah, I copied it by accident, but like because we're going to use the name. So first we're going to extract the secret. We're going to save it in a directory we have. So using the command OC extract secret, and then we're going to provide it with the name of the secret. And make sure this is actually using dash command is just going to output it for us in the command line. We're going to take a look at what is inside this secret. And as you can see, it has like a key certificate pair starting with the TLS.crt. The name of it is TLS.crt and TLS.key. Now we're going to need to save it. So we can use the same command. And then we're going to just save it in a temporary directory. Now we have created it in, once we extracted it, it generated for us two files, tls.crt and tls.key. Next thing is we're going to create the edge route. First thing is I would recommend to actually delete the route that we just had. It can be using like the name of the route or --o. And then we're going to create the route using the command, which is like, if you take a look at it, what does it say? Like the command is generic when you want to create it, whether it was route, edge, pass through, or reencrypt. So OC create route edge, and then we're providing with the service name. And then it is very important. These are required parameters, the key and the certificate, which we have just installed. Which we have just saved in our directory. So once you created, you can also provide a host name. But in case if you do not provide a host name for your cluster on IBM Cloud, it will be auto-generated. If you have a domain name, you can provide it as well. So if we take like OC get routes, you will notice as well that the type of determination is edge here. If we take a look at it at the top here, there's no termination type, it's just empty. So let's actually visit the page. Okay, so this one is actually cached, so it might take some time. It's currently unavailable because we have to provide like the HTTPS protocol at the beginning. Now there are different ways when you like, let's say you want to access a website or web page, and that it might not start, like usually we do not enter HTTPS. And there are different ways where we can make it like work however we want. So like there is do nothing, or do not let, like, which is not letting them access it, or if you want them to be redirected to it, or if you want to just allow an insecure connection to your application. So there are three options that you can make when you first create your router using Edge or pass-through or Reencrypt. The default one is do nothing, so you have to write HTTPS. And as you can see here, you have the connection is secure. There is a certificate and it is shown as valid. And if you click on it, you will see information on it, on your certificate. It's issued to, for example, in my case, for the cluster, the domain of the cluster I'm using. And there are more information and details on it here. And like the signature and version and certification path. Now we have created the edge route. We're going to take a look at the pass-through route. Now for the pass-through route, we will be using a different application because there has to be some configurations when it comes to pass-through routes and re-encryption route, because they are encrypted on the pod level, unlike the edge route. So we have to keep that in mind. So we have created an image that that is encrypted on the pod level, so we can do that. And this is the YAML file, the YAML definition, which consists of a deployment config and a service. And you can take a look at it. If you read it, it's very simple. All the work we have done is in the image, on the image side. We have also specified the volume mount, because we will have to mount the secret to a volume so we can use it, so we can actually make it work. Without, if you do not mount your secret, it won't really work. And we have also specified that the port is 8443. Now, let's just create it using the OC create command. And if you take a look at your pod, it's currently creating the container. It shouldn't take long. And then I'm just going to take a look at the services we have. So the application is written in Golang, as you can see. You just need to make sure that the pod has been created successfully. Now, while it creates, let's take a look at the next command, which is to create a TLS certificate. Like you mentioned earlier, when we want to create a pass-through route, we have to provide a secret that includes the certificate and the key. So it's very simple, using OC create secret, and then the type of the secret is TLS, and then provide with the name of the secret and the parameters, like what is inside of it, which is the certificate and the path to it, and then the key and the path to the key. So let's take a look again at our pods. A bit odd that is taking time, but
I think when we mount the certificates, the container is going to start running.
I think so, yeah. Most likely it's waiting for the mount. Yes, like in some cases when you do not mount it, like it usually gives an error or a crash loop back of error, something like that. So after we created the secret, we have to mount the secret to the volume using the second command, which is oc set volume, and then the deployment config, which we have created earlier, and then we're adding it, and the type is secret. We're mounting it to the path, which is we have shown earlier. You can see it in the deployment config name, and then the name of the name is a certificate, and the secret name is my cert. And as you can see, it's currently in running state, and that's because we have mounted the volume. So next thing is we need to create the route. So to create the pass-through route, it's very simple, same command, but since you have created a secret inside the pod, you don't really have to provide the parameters of certificate and key pair. You can just go with OC create pass-through, and then the name of the service, name of the route, and then the name of the service that you have. And then if you take a look at OC get routes, so this is like I mentioned earlier, and if you don't provide with HTTPS, you have to make changes to it, or just add HTTPS when you want to access the route. And this is our application. It says hello from Go HTTPS, and as you can see, it is secure, providing us with certificate information. If you try to deploy the same application without the secret and without the without the volume, you will notice that it's not going to work. It will show you that the application is not available or it's insecure and so on. And you can actually also try to test it using curl commands, for example, so let's say that OC debug DC running HTTPS. Yeah, I forgot one thing, I think. Oh yeah, I can actually get it from here. So in this case, for example, we want to, I'm going to try out to access the pods inside the cluster, for example. So I have created a debug node, debug pod of the Golang HTTPS, and I want to try to access the guestbook, and it should work. So if you just use OC get SVC and then just take the IP address of it. I think we have to provide with a port if it doesn't work. Yeah. Wait a second. So we could try anything, for example. Let me take a look at the port of it.
It's port 8443.
Okay, 8443. And hopefully it will work because I'm just trying it now. But usually, if you want to try out how it works, if you can access it inside the cluster, just use OC debug. and then the name of your deployment application, and you can use the cluster IP or the private IP. I think it didn't work for this one here. I think I have to provide. Oh God. Maybe using this. We'll see. But yeah, like you can use curl command to try to access your application, and you can use the same thing. So if you try to access, for example, the Golang application without a certificate, you will notice that it is actually inaccessible. So that leads us to the end of this like tutorial. So we just wanted to introduce to you like different routes on OpenShift and how you can like create them and how to secure your application. And we really hope that you learned from us. I think, Youssef, you might want to wrap up the session. So I'll hand over to you.
Yeah, so thank you, Masa. So let me share my screen now. All right, so thank you, Masa, for the hands-on workshop. So just to recap what we talked about today, there are different security concerns in microservices, such as data management, API vulnerability, and the authentication of requests. And because of these issues, we deploy different secure routes. So we have the edge route, pass-through, and the Reencrypt. In a clear route, the connection is always unencrypted, so you are vulnerable to phishing and man-in-the-middle attacks. In the edge route, the connection is encrypted from the client to the router, or you can name it the reverse proxy, but it is not encrypted to the pod or to your application. In the pass-through, the connection is not encrypted from the router; it's encrypted from the application side. So the certificates and everything is set up on the application, and it is one transport layer security, and it is one TLS session and connection set up from the client to the application. Lastly, we have the Reencrypt, which encrypts the connection from the client to the router with one TLS or with one certificate, and from the router to the application, the router re-encrypts it again. So just again for the edge and the clear routes, if you notice, the application itself does not need to support TLS or SSL in general. So you don't need to have any certificates set up on your application if you're deploying it using a clear or edge route. However, if you're deploying it through a Reencrypt or a pass-through, you would need the certificates to be on your application, and it would need to support TLS or SSL. So lastly, we would like to share some resources with you guys. So if you want to check out what is a self-signed certificate, you can check out OpenSSL. There's also a blog on how to create an end-to-end encryption approach for our application for Red Hat Openshift. So thank you once again. We are really glad to be here with you guys today. If you have any questions, whether it's related to this this talk today or not, you can send us an email, and we'll be really happy to get back to you. So thank you guys once again.
Thank you, Youssef. Thank you, Masa. So anybody has any questions, we could do like an interaction session. If anybody has any questions, we can take, yeah, I'll wait for that. All right. Yes, anybody?
Yalo, here one question. Do we have any information on how it is different when it is done in say Tanzu or say some Rancher or with say DY own tool or something like that? Any information on this?
Can you explain more?
Okay, so do we have any differences how OpenShift routes are different from say Tanzu or say Rancher or any competitive information on this part?
Well, in terms of the routes themselves, you have the certificates supplied. You don't have to like provide your own certificates. There's certificates signed from the OpenShift cluster itself. So in terms of checking the authenticity and genuinity of the host, it is set up for you straightforwardly. If you also want to set up your own certificates, you can do so. You can do it if you feel like it. So
let me put it other way around. So my question is, how is it done in say VMware Tanzu or say Rancher? Is OpenShift and all other competing products doing it in the same manner, or there is some difference? Any information on that?
Oh, you mean the approach in general, whether irrespective of the platforms, is it going to be the same? I guess the approach to securing the microservices with the best practice approach as mentioned in the demo today, I guess it remains the same. Masa or Youssef, any other way you want to address it?
All four supports all the four types?
I'm not
yeah.
sure.
So if you want to talk about the the different routes for microservices, yeah. So in some cases you don't have to like deploy a specific type of route for all of your microservices. So you can use different routes depending on what is your need. So let's say you don't want to encrypt the packets sent from internally, then it's fine. So
Cool. Yeah, so Rushil says that the basics remains the same because all the companies use Kubernetes as orchestration engine, and whether it's Rancher or Tensor. Yes, I guess the base APIs still remain the same. So yeah.
Thank you.
Thank you, Yao. Thank you, Youssef. Anybody else? Any questions? All right, cool. We have a next session by Rushil and Rutivik. Rushil is here. Rutivik, I think, is away for personal reasons. So do you guys want to take like a 5-minute break, or do we continue with the session? I'm okay with anything. Let's take a quick 5-minute break, Rushil says. Well, he's a presenter, so let's take a 5-minute break, and we will regroup. So I guess it's 12 right now, so 12:05 to the by time. Rushil is in Belgium, so Rushil 5 minutes.
Hey guys, hi, can you hear me?
Yeah, Rushil, we can hear you.
Okay, perfect. I was just checking my mic and everything.
Okay.
Sometimes the computer get nervous during presentations.
Yes. The curse of live demos.
Yeah. Let me check if the camera is also working fine. Okay. I think you can see me now as well, right?
Yes.
Like this is what I was explaining in the morning. See.
Yeah, I would not wake up. I would be hibernating. In that
It's completely It's completely white. It's a blizzard out there. So just a few hours back, we received a warning that there'll be snow.
Oh.
Hmm. So there's a snow warning today, and yesterday it was fine, and 2 days back it was like 18 or 19 degrees, and in 2 days it's gone down to 1 degree.
Holy.
So yeah, it's a pretty it's a huge change because I was in India for like 29 years. I lived in Rajasthan. Then I
Okay.
moved to Pune, and Rajasthan and Dubai in terms of weather, it's exactly the same.
Yeah,
Apart
desert
from
regions. Yeah.
apart from the cherry on top with Dubai, that there's a sea there, right? So you
Yeah.
can go there. Uh,
Correct.
but yeah, in my hometown Jaipur as well, it gets as hot as 50 degrees sometimes, but 45 46 degrees normal in summertime.
Sometime.
It rains very less because there's a desert, so I never felt like I left home when I was in Dubai.
Dubai. Yeah. So you've been in Belgium for like 2 weeks now.
Yeah, 2 weeks. So actually I was for initially I was planning to move to Google Dubai,
Okay.
but it didn't work out, so they asked me to join Google Sweden, but
Okay.
that also didn't work out. But at the end they said that yeah, this Belgium gig works out pretty well, so I was okay with it.
Perfect. Perfect.
But it's fine, it's good, it's very good. This is the first time that I'm in Europe, and this is the first time that I saw this level of cold temperatures. The day I landed here, it was pretty fun because it started snowing from the very next day.
Mm-hmm.
So I saw the snow for the first time in my life as well. So that was also a pretty neat
Yeah.
experience. Then we went out. It was -8 or -13 one day as well. And uh, my Belgian colleagues told me that this is the first time in 11 or 12 years that it has gone this cold. Usually it doesn't go below zero in Belgium. It's not
Belgium.
a cold country.
Yeah.
But yeah, it was fun. It's still fun. I'm thinking of going
Congratulations.
out today.
Congratulations on your move, and yeah, wish you all the best
Yeah,
there. Yeah.
thanks, man. I really miss Dubai, and it's a lot of fun in Dubai. Yeah,
Correct.
especially because I used to live in Marina, and in during lockdown, I used to just walk to the beach if I was bored. But that's not an option here. You just have to, walk. And this is not even the best time, right? Spring is the best time to visit Europe, or summers. So I'm
Yeah.
just keen on to wait. I'm just waiting for this to turn beautiful the way Europe is.
Correct. And you have better vaccine rollouts, I guess. In time for the weather, right weather, you'll be able to roam around.
Yeah,
Yeah.
let's hope, man.
Correct.
Okay, let's
So let's
let me
start.
share my screen.
Yeah, we'll start with a
One
quick
sec.
introduction
Okay.
of you. I think we
Yeah,
did
yeah.
a quick introduction already. Yeah. So yeah, can get to it.
Okay, let me know when you can see my screen.
Cool. So Rutvik won't be joining us. It'll be Rushil. Yeah.
Yeah, so Rutvik has already recorded and sent over a video.
Mm-hmm.
Actually, his sister is I think it's his nephew's first birthday.
Oh, okay.
So yeah, but he really loves to contribute to open source, and we have actually gone to a lot of talks. We went to Thailand and Thailand and Vietnam,
Oh,
and in Bangalore as well, and in Pune multiple times we have presented together. So
nice.
he actually recorded this at 4 a.m. in the morning because he had to leave at 8 a.m.
Damn. Okay.
Uh, so I really love his dedication. I don't think that I can do something like this. So yeah, but we'll try for the next time that he is also available, because his expertise is in monitoring Grafana, Prometheus, and tools like these. So a
Sweet.
very nice ecosystem that he has been working at Red Hat. So
Nice.
okay, it's time. Let's start. Let
Yeah.
me give a quick introduction of myself. So good morning, good afternoon, guys. It's the morning here in Belgium, and good afternoon for my Dubai friends. Myself Rushil. I have worked at Red Hat, and guys, thanks a lot for that presentation on OpenShift, because I have been doing that for a long time and it brings back a lot of good memories. I have worked on OpenShift extensively. I have tested that product, and uh, today we are using OKD, which is the upstream open source offering of OpenShift. So Kubernetes and machine learning. So let's start. So a quick disclaimer, guys. This is, as I mentioned, I work for Google and Rutvik works for Red Hat, but we are not sharing any enterprise products today. We are not focusing on anything enterprise. We are completely focusing on open source contribution, and this is our personal open source contribution. So just a quick word before we start. So let's
Perfect.
quickly begin with our first slide, like what is Kubernetes. So uh, if I explain in a quick manner, let's see the methods of application deployment which used to happen some time ago, like a decade or so, more than a decade. The traditional deployment method, right? So we used to have a hardware, then a layer of operating system on top of that, and then you can deploy one or more than one applications, right? So this is the simple, very basic design of application deployment. After a long time, this completely changed because companies like VMware and others, they created something called a hypervisor. So when you have hardware, you have a layer of operating system on top of that. And on top of that, you have a layer of a software called a hypervisor. So what does a hypervisor do? It simply takes leverage of the hardware and the operating system and creates virtualized environments, a virtual machine. So that is like, it's like Inception, right? You have a operating system inside an operating system, and I think these days hypervisor supports like nested virtualization also. It's pretty dope. You have operating system inside an operating system inside an operating system. So yeah, that's pretty cool. So on these different operating system on a single hardware, you can deploy different virtual machines, and on those different virtual machines, you can deploy multiple applications. You have these VLANs over there. You have completely segregated network, so it works pretty well. But there were again some problems with that kind of deployment. Like you have to have a big hardware, right? You have to have a data center. You need to have a lot of hard disk. And for a single operating system, let's say if you're installing CentOS, right? So CentOS eats up around 4 to 5 GBs. And if you want to deploy 2000 different application on 2000 different VMs, you need to have that much of hard disk available just for the operating system, right? So it's a wastage, right? Because if it's just a static page, but it is mandated, like it was mandated when I was working at Wipro in a data center, that every single application must have its own operating system, its own resources. So it's completely segregated because it was a government-based facility, and they had this some mandatory guidelines. So we had to use different OS, but eventually you'll run out of that, right? You'll run out of that hardware. So what you will do? Will you add more hardware? Maybe you can if you want to, but at one point in time it will become very expensive to maintain, right? Because you have your own data center, you have to spend more on electricity, and a lot of different things, a lot of different aspects are associated with it, right? Then comes the containerized deployment, which solves a lot of issues with the virtualized deployment. Like you have your hardware, then operating system, then you have something called a container runtime, like Docker, Podman, Cryo, Rocket, right? What they do is they leverage two very neat functionalities of the kernel, which is the C groups and kernel namespaces. What they do is when you deploy an application in a container, they simply use the resources from the kernel and they run as a process. Every single process in a Linux machine is a separate entity, and it is segregated using these two kernel features, the C groups and your namespaces. this functionality is a feature of Linux kernel. So that's why initially this was not available with Windows. Now it is available, but with a workaround, because Windows kernel still does not support uh, C groups and namespaces the way Linux does. But it solves a lot of issues. Like you can have more than 100 deployments in a single operating system on a single machine. Like it was not possible earlier with the virtualized deployment methodologies. Also, it solves a huge issue of developers, that it runs on my machine, why doesn't it run on yours, right? Because if you have containerized something, you have created a Docker file, it runs exactly in the same manner that it runs on your laptop. So it will run exactly the same on every laptop in the world. So it's also a huge issue. So that was a little intro of Kubernetes. Now let's see what does Kubernetes provide, right? So some of the basic functionalities I've narrowed it down here, like service discovery, load balancing, or storage orchestration, self-healing, secret management, like we just saw in the amazing presentation regarding securing your containers, how to manage secrets, right? And some of the other functionalities include like cluster level auto scaling, right? So it is a very good feature if you have a sudden increase in your workload, you guys went viral and you need more resources. So Kubernetes can understand that, and it adds more resources, it adds more hardware on its own. So this is also a neat feature I would like to do, and show you guys that at some point in time, because it's pretty fun. But yes, this is just the basic functionalities of Kubernetes, that what does it provide. Okay, now let's see a couple more points regarding our AI and ML capabilities. So let's see, what is machine learning. Now we hear these terms a lot these days, like machine learning, artificial intelligence, deep learning, and natural language processing (NLP). But what does these things mean? Like how are they correlated with each other? So I'll explain one line about each of these pretty quickly. So see, hold on, I think I skipped. Yeah, here. So AI versus ML versus deep learning. So artificial intelligence, when we say what is this AI, we see this in movies, we see this in the like Terminator and Avengers. So this is the broad discipline of creating intelligent machines, artificial intelligence. Okay. Then comes machine learning. So machine learning is a subset of artificial intelligence, which refers to systems that can learn from experience. Okay. Which is called heuristics. So computers, we generally speak about computer and say that computers have no heuristics, but humans have, which means if we have done something wrong in the past, like we spilled coffee, right? Like I'm having a coffee right here and I spill it. So I'll remember it. Like I have spilled it in the past. Now I remember that, yeah, I spilled it in the past. Now I'm not going to do it because I'll be more careful. If a computer does it, if there's an error on your system, on your operating system or whatever, it keeps on throwing that error, right? Because it's not aware, it's not self-aware. So it will not understand that. But now we are trying to develop machines which will do it, which will learn it, which will ask you that, yes, yes, you are you know aware of this error, correct? So I will not show it again. uh, Computers will become a little more polite, I think. Then comes DL, deep learning. So deep learning refers to the system that can learn, sorry, uh, yeah, that can learn from experience on large data sets. Okay, so that's why DL is a subset of ML, which is a subset of AI. So that's how these things are interconnected. Then there are some other terms like artificial neural networks, right? So just like human neural networks, scientists are trying to understand how neurons are connected to each other and how they communicate. So if you have read about it or seen Elon Musk's one of Elon Musk's initiatives, which is Neuralink, right? So what he's trying to do is he's trying to implant a chip in your brain, which will communicate with your brain, and then he'll gather data from there. So it's like pretty nice because it will be able to monitor health issues. It will be able to monitor your brain activity. And sometimes some unfortunate people who are fighting with cancer and they develop brain cancer, it's still not uh, understandable that how it happens. So I think this will work pretty. It has a lot of great opportunities in pharmaceutical and biological domain. Then you have automated speech recognition, which recognizes your speech and things like that. So as I mentioned, artificial intelligence and modern technology, like in simulation modeling, in image analytics, audio analytics, visualization, robotics, etc. Social network analysis, yes, IoTs. So like you have things like Roombas in your room. It'll learn that it's a vacuum cleaner, right? It's just a vacuum cleaner, but it learns where to clean, or if he has cleaned, if that machine has cleaned at a specific place, it will not clean there again, so that it's not stuck at a single point. So machines are obviously they're learning now, right? Then there is a specific term called AGI, artificial general intelligence. So first we need to reach that point. AGI means uh, an intelligence which is closest to human beings, also which is self-aware. So it will take a long time for us to reach there. I think more than a century, because it is a long process. So yeah, let's take a look at the next slide about coming back to the topic, which is Kubernetes with machine learning. So one of the points that I initially mentioned, that Kubernetes will add more nodes, right? So it does it through cluster level auto scaling. But the issue is that DevOps practitioners don't know enough data science, and data scientists don't know enough DevOps. So if people who are in DevOps, they want to work with machine learning and Kubernetes, they don't need to understand data science, because there are several tools which were developed just to ease this issue. So that is Kubeflow. So Kubeflow is a E2E machine learning pipeline. So let me quickly hand over to my colleague Rutvik, because he will be presenting on this demo and some of the other features. So let me quickly play the recording and let me know if you are able to hear it. Oh, guys, are you able to hear?
No.
No,
It's
not
not
yet.
not audible. Okay, hold on. Let me check. Hold on. Okay. Wait, let me disconnect this first.
Should you be downloading that file? Rushil, you there? Hello. Oh, I think it's stuck for Rushil. Just give it a minute.
Yeah, if you can also have that file and try it from your side, that is another option you can try.
Cool. You're going to be sending it to me?
Ask Sushil.
Oh, who's this? This is Rutvik.
No, Yalo here.
Yalo. Okay, Yalo.
So you don't have the file, right?
No, I don't have the file. Rushil has. He just texted me.
So which app is this?
This is 8x8, which is managed Jitsi. Jitsi is an open source video conferencing tool. So 8x8 is the managed version of it, which is pretty cheap. Like I think it's $12 per year, and yeah.
Hi guys, hi. Sorry, I think my laptop got stuck. Exactly what I was speaking about
Oh, okay.
during conferences. Yeah, this has to happen. I don't know why with me. Just tell me one thing. Were you able to hear the recording that I played?
No,
Okay.
but was that you playing from the preview, or it was a downloaded file?
Wait. It was from YouTube only.
Okay. So I think in the mic settings, probably.
Yeah, I'm checking that.
Yeah, if you take the system audio, probably should pick up from there.
Yeah, I have chosen MacBook microphone only.
Okay. Let's give it a shot again.
Yeah, hold on. Can you hear now?
Yes, I mean I can hear you, but we don't see the screen yet.
Okay, yeah. Let me share. Hold on. If you are able to hear it, let me share.
Oh, okay, okay.
Yeah, I've hold on. Let me share. Let me know if you can see now.
Yes, we can.
Okay.
No, not audible.
Yes, yes. Tell me, is there an issue?
Not audible. I mean, I couldn't hear, I guess.
Okay.
The same for others too.
Let me check. Oh, let me play from downloads once. Maybe
Yeah.
it can work. Hold on. Is it? Are you able to hear something now?
No.
Okay, let me do. Okay,
Yeah.
let me do one thing. Then what I will do is I'll mute him, and let me play the video, and I'll explain what he's doing. I think
Okay.
that will work. Just 1 minute.
There's an option within this app where it's share a YouTube video. You try that?
Yeah, let me try that also. Hold on.
In the bottom right, next to a
Yeah.
shield.
Yeah. Okay, I think it's still throwing some error. Let me play it and I'll explain everything.
Cool,
No
cool,
issue.
cool.
Let me share the video. Okay, is my screen audible? Oh, visible?
It's the 8x8 screen.
No.
Okay, no. Can you see that this current screen now?
No.
Okay, hold on again then. I don't know why.
Yeah, I guess now. Rushil, I think you're on mute.
Yeah, visible now, right?
Yeah, visible.
Perfect. Okay, let me quickly start it. Okay, guys, so let's talk about Kubeflow. Now, I'll be showing you a quick demo. Okay, so now here with this the issue that I mentioned, that the DevOps guys don't know enough data science, and the data scientists don't know enough DevOps, right? So the demo. So let's talk about Kubeflow. So what Kubeflow is? Okay, so Kubeflow. So what Kubeflow is? Kubeflow is a cloud native platform for machine learning. So what Google did? Google created an internal machine learning pipeline, which works as a machine learning toolkit, and it is embedded with Kubernetes. So it is specific for your uh, microservices architecture. Okay, and it also supports multiple machine learning frameworks like KSonnet, TensorFlow, JupyterHub. Okay, Just once, guys, you're able to hear me and you're able to see the screen, right?
Yes.
Perfect.
Yes.
Okay, awesome. So Kubeflow, I was just speaking about Kubeflow, right? So like case on it, TensorFlow, JupyterHub. So what these things are, we'll see quickly. Now, in the demo that I'll be showing, it's not like a big demo. It's just a simple machine learning algo which will solve a simple mathematical problem. So how we'll do it, how we'll implement it, and as I mentioned, we'll be using OKD. So let me go to the next slide quickly. Okay. Yeah. Okay. So what is the use case of Kubeflow? So when should we consider using Kubeflow? So we need to use Kubeflow if we want to train some models, right? So what models? So when we talk about machine learning, there are different models. So what those models do are, we create these models and we train these models, right? So just like we train an employee or we train some students, right? So we create these models and we train them for doing various things, right? Things like your image recognition, speech recognition, or whatever you want to do, right? And to train it, we need to have some parameters, right? So you'll create an algorithm, you'll create some specific some specific set of rules. Okay, so in order to do that, we use JupyterHub. So what JupyterHub is? JupyterHub is a tool which has Jupyter notebooks. Okay, in these notebooks you launch training jobs. Okay, these training jobs will take leverage of the CPU or the GPU available in your infrastructure. Let me go to the next slide. Okay, 1 second. Yeah. Okay. So now the components that we need in order to implement ML pipeline in your Kubernetes environment. Now, all of these components which are mentioned here, these are mandatory components for a single machine learning pipeline. Okay, so as I mentioned, JupyterHub, it's a tool where you have your Jupyter notebooks in order to uh, implement your algorithms for your training. Then you have TensorFlow. Okay, the TensorFlow is the actual tool which starts the training. So it's called flow of tensors. And what these tensors are the components which starts to learn. Okay, then you have workflows, right? So like we have Jenkins pipelines, we have Argo. These are for the workflows. Then Selden Core for complex interface of non-TensorFlow Python models. Then reverse proxy. But Jupyter Notebooks and TensorFlow, these are the most important components. So let's take a look of how this ML pipeline workflow works. So this is the basic understanding of how a simple training model will work, right? So on the first category, we have data management. So there are three product categories here. The first one is data management. Then you have the experimentation, and then the product deployment. Okay, so let's quickly take a look at what these means. Hold 1 second. So what really happens in the first phase in the data management? So you want to develop your model based on what data you have initially, right? And then you want to test it. So this is, you can consider this as a testing phase. Okay, so you acquire the data, then you prepare that data, and based on that you prepare a development model. So it goes to the experimentation phase, right? Then you train that model. Let's take an example of a speech recognition. Okay, so you have a speech recognition tool, you have everything aligned, you have your model. Then you train it to understand speech. So in the Middle East, right, in UAE is a multicultural environment, right? That's one of the beauties of UAE. People who live in UAE, they have different accents, right? People in UAE are from Europe, from India, from Pakistan, from other Middle Eastern countries, from African countries, right? Machine needs to learn how to understand a single sentence from all these different kind of accents, right? So you start working on that, then you train it, then you check for the accuracy of it. Okay, like for example, the machine is able to understand me, but maybe it's not able to understand some other person, right? Maybe he's from a different, let's say it's from Germany. Okay, and then when that is a specific person speaks in English, the accent is little bit different. So you go back to your data management, you acquire that data again, you prepare, you change the model, you go back to training, then you again try to experiment. If the accuracy is reached, then you go to the prediction or production deployment part. Okay, then there comes the production deployment and the prediction phase, where it actually is able to predict what kind of accent is coming from the person who is speaking. Okay, then you also have this component right here, which is called the monitoring and alerting. So basically what monitoring or alerting means, monitoring means that you will consistently monitor during the production deployment and when it is live how it is functioning, because obviously if you have it in if you have deployed in production, you will have production issues, you will collect more data, and you will go back to the data acquisition part. Then you will start preparing it again, you'll change the model, you'll train it again, you'll check for the validation, then you'll deploy, let's say speech recognition 1.2, the latest with some bug fixes, then 1.3, then 1.4, so something like that. Okay, so let me quickly stop here because this is too much. Do you have any confusion in this ML pipeline workflow, or do you have any questions till now? If you have, let me know. I'll quickly answer them, because in order to move forward you might need to have a little bit of understanding what we just saw.
I think I'm good. I'm quite familiar with these concepts. There's some other topics that I would like to discuss with you, but we'll discuss that at the end.
Okay, cool. Okay,
Others, if
so
there's anything, just put in the chat and we will revert to the
perfect. Okay, perfect. So let's move to TensorFlow. So what TensorFlow actually is, let's see the definition and some other things. So TensorFlow comes from the operations which the neural network performs, right? The actual neural networks, like our brain. So there are multidimensional data arrays which are called tensors. Okay, TensorFlow has flexibility of representation, and the beauty of it is because ML algorithms and ML calculation needs a lot of resources. GPUs are usually faster than CPU in calculating this kind of workload. So TensorFlow leverages all the power from a GPU in your environment. It also supports parallel computations. It's highly scalable, and it has integration with most of the open source tools in this machine learning workspace. So let's move on to the next phase and see what JupyterHub is. So yeah, so as I mentioned earlier regarding JupyterHub, so let me quickly tell you what basically we need it for. So we use Jupyter notebooks or Jupyter servers. So these Jupyter notebooks, as I mentioned earlier, you need to have some algorithms, you need to have some model, right? So we use these notebooks. You can write them in Python or Tornado, right? And you can configure with HTTP proxy or Node HTTP proxy, and you can receive the request from your client's browser directly to your Jupyter server. Yeah, so let's see the deployment process of JupyterHub. Okay, so when Jupyter when you start your JupyterHub, it has a component called the agent, and that agent is called a hub, and that will start an instance of the proxy that I just mentioned. It will listen for the requests. When it receives a request, it turns it over to the actual hub, and then it decides for the new whether a new instance is required or not, and then it will attach this integration between the user and the Jupyter so that it can actually start functioning. So it's better if you look at how it works. So quickly see the demo of it. 1 second. Yeah. Okay. So what we are using here is OKD, as I mentioned in the beginning. OKD is the open source and upstream version of OpenShift. So let's start that. Okay. So what we are doing here is we are creating a new project called Kubeflow. And then I'm initiating the OKD environment, OKD OpenShift environment. Okay. So the one of the components that I mentioned earlier, the KSonnet environment. So the KSonnet component will create all the APIs which are required for OpenShift or OKD to communicate with OpenShift. So this is the KSonnet. Okay. So basically what this is doing is it is creating a kind of a virtual environment within OpenShift for our machine learning pipelines. Okay. So when I say virtual environment, what I basically mean is if you have worked on Python environments, right? So you can create a virtual Python environment where you can download those packages and test them out, right? So it's similar to that. So what currently is happening on this screen is, let me go back again here. So here, as you see in this specific command, environment set default namespace, and so this is that KSonnet environment that I was talking about, that virtual environment. Okay, so now what we are doing is we are installing the Kubeflow packages, the TensorFlow and other required components. So we have, I think, yeah, so it's installing now. It's downloaded, retrieved 5 files. Okay, so now what we are going to do is we need to create some SCCs. So we'll create SCCs for this. So what SCCs are? SCCs are security context constraints. So these are special permissions in your OpenShift account or OKDs or any microservices accounts. Okay, so basically now what's happening is it's creating the core, the Kubeflow. It's creating and installing and applying all the changes. It's applying the configuration maps. It's applying the, yeah, it's rolling out the ambassador service, the proxy service. Let's see, yeah, it's finished now. The roles and all, everything is rolled out. So if I show you OCGet all, so in OCGet all you can see, hold on, yeah. So here you can see the pods have been rolled out. So these pods are the same components which we just discussed, like we need ambassador, we need TensorFlow, we need KSonnet. right? So okay, so basically this is not a production ready environment. This is just for the sake of one single application. So because I currently don't have any GPU, just a single CPU, so we cannot run huge workloads. But yeah, this will work fine. So let's see if the pods are in ready state. They are still coming up. Okay, so the pods are coming up. So definitely for actual workloads and actual models, we'll definitely need higher end hardware, GPUs, and a bigger cluster, a much bigger and better cluster. But this is just to show how these services work. It's actually pretty easy to install it now. So let's see. So what we have done is created a route, because we need to access the web application. So I think we have that. Yeah, it's created. Let's see if we can access this. So basically the required pods are there, like Ambassador, TensorFlow Hub, and this the TensorFlow dashboard. So because we have a TensorFlow Hub, what now we are going to do is we need to create a route to access the TensorFlow Hub, and that route will give us access to the Jupyter Hub notebooks. So let's see. Yeah, I think it's created already. Let's see if we are able to access the TensorFlow Hub UI. One second. Yeah. Okay. So this is the the TensorFlow Hub, the TF Hub that we were speaking of. Let's log in with the default credentials and let's start the server. So here you can select which image you want to choose and how much resources you want to give. So here you can specify if you have a GPU and how many number of GPUs you would like to leverage to use with your machine learning pipelines. So let's spawn a JupyterHub notebook. This will initiate a Jupyter server, which will then be able to receive requests using the proxy, the Ambassador proxy. So let's spawn it. So this must have created a new pod, the Jupyter admin. So yeah, right here, it has created a pod called Jupyter admin, and the server is now starting up. So this is a new route for the notebook, server. So let's see. So this is the interface where we can put your code, your Python code, or the complex Jupyter algorithms, the training algorithms basically. So this is the place where you actually put your training code, the model, the code for your model. So this here right now, because this is a very simple one, what we are doing is we're just training it to do some simple mathematical calculation, the matrix multiplication. So this is some Python library that we imported, and this is the first matrix and this is the second matrix. So this is the output of that matrix, and this was the demo part. So let me go back to the slides once again. Hold on. Yeah. Okay. So I hope this demo was like a little bit, uh, uh, informative for you guys, because yeah, we had a little bit of hiccup in the beginning, but actually my entire goal here was to jump all of you guys on this AI and ML race. That's why I kept this to the bare minimum, right? Because this has a lot to explore here, and as I mentioned to Arjun as well in the beginning, even I have just recently started working on this. So please forgive me if I have said something which was not correct. Correct me. I'm also learning, just like you guys. So let me know if you think that something we can add to this, or or if you want me to omit something, like this was not correct or this has been updated, because Arjun said that yes, come on, we are also learning. So I was also a little bit nervous in the beginning, but yes. What I want to say now is, do you have any questions related to these components or the demo? So let's take that first.
Hi, Rushil.
Yeah,
Yes, I mean, I guess that's the whole point about the community. Everyone of all expertise levels can come in and participate. It's always inclusive. So it's been a wonderful session. I really liked how a lot of open source components and particularly things under the Cloud Native Computing Foundation umbrella
yeah,
projects have been included stitched over here, right?
exactly.
Generally, people have been hesitant to run data workloads and particularly ML type of workloads on Kubernetes,
Exactly.
primarily because of that storage layer, right? Where you generally for big data workloads, you kind of need strong persistent storage, right?
True.
Yeah, and Kubernetes initially was more favorable or inclined towards stateless applications, right?
Exactly.
So, I mean, there's still a lot of research going on. I think Portworx and other guys are trying to bridge that gap, and that's a gap that's being continuously researched to plug. Um, so, I mean, yeah, machine learning, but the pure meaning of it, like, yes, it is. There was an interesting line that one of the conferences there was a head of data science at Property trying to say it's
Yeah.
a sequence of failures that eventually bring it to the desirable state. So you have
Yes,
to be
true.
ready for failures when you embrace machine learning. Could you speak
Exactly.
a little bit about like there are various components? What interested me more, and I think is Argo, right? And I'm not a very hands-on technical person. I heard about Argo primarily from various podcasts I listened to. That included people from Lyft engineering primarily, and
Yeah.
who have been speaking widely about Argo and like how they kind of have used that as one of their mainstream tool chain, right? When it comes to CI/CD part, the side of
Mm.
things. So, is that just the scope of Argo, or there is something called Argo workflows? Like in the big data world, there was a Airbnb project called Apache Airflow, which is to orchestrate data jobs or schedule and orchestrate them.
Okay.
Uh,
Yeah. Let me. Yeah.
yeah,
Yeah. Yeah. Okay.
could you
So
talk about it?
see. Let me give you a small and quick brief of what I actually know about it, because
Okay,
as I
okay.
mentioned, I'm also learning it. But yeah, first I would like to tell you why Argo is used here, and
Hmm.
what's the reason behind it. So Argo is used as an operator here. So let me quickly tell you what operators are. So
Okay.
in Kubernetes world, operators are a special, very nice tools. Operators are very nice tools. So the main reason behind using operators is to minimize the human intervention required to do certain jobs. For
Hmm.
example, if you're using a MySQL operator, what that MySQL operator will do is it will handle a lot of the work which you manually do for databases. Okay, like updating tables or saving them or taking snapshots, right? So some of these
Okay.
things are done by operators. So these days, a lot of different companies are creating their own operators. You can also create your own operator if you have any specific tool that you have recently developed. Now coming to Argo, Argo is a pipeline like a CD. It's like a CD pipeline, and it is being used in your ML ecosystem, because obviously when you are talking about ML, we need minimum human intervention. That's the goal, is right. So that's the
Correct.
goal. So automating pipelines. That's what Argo is doing for in the machine learning space. You can say that Argo is the Jenkins equivalent of machine learning.
Okay.
So it'll learn from your deployment strategies, and then it'll learn how to do these automated deployments, and maybe it might be used later on for other type of workloads as well. So that's my basic understanding of what Argo is. But yeah, it's specifically designed for machine learning workloads, because if you remember, I showed architecture of this training model, right?
Correct.
Experimentation phase, then the learning phase, and then the deployment phase. So this entire model, you can control all of this with uh, Argo. So that's why it's preferred.
Cool. Cool. Understand. No, so I think it becomes more Kubernetes native, right? So where
Exactly.
probably each of those jobs would be an independent application of sorts, and Argo kind of orchestrates that.
Exactly. So Argo kind of orchestrates all of the machine learning related, because see, as I mentioned, you have to have specific requirements, like TensorFlow is there, JupyterHub is there, Ambassador is there, right? So Argo understand all of this.
Cool.
That's what my understanding is, because I haven't worked extensively on this, but I really look forward to working on all of these tools.
Correct.
And I'll try to get into this domain as soon as possible now, because this interests me a lot. So yeah. So guys, any other question, anything else before we conclude our session from
Anybody?
anyone?
Anybody else? I think.
So,
Go ahead, Dev.
no, I mean, great session. I mean, so this actually gives a complete idea of all the components required. So I'm really happy about the session.
Thanks, man. Thanks.
Again on Argo part, Arjun, so Jenkins was not cloud native, right? Then Jenkins X came, it was kind of cloud native, and it does multiple things. But Argo does just one thing very specifically, that is the workflow part.
Okay.
And it does it very well, and it's cloud native. It got a lot of popularity. So yeah, both of you are right. So yeah, it's equivalent to Jenkins X in terms of comparison, direct comparison.
Yeah.
Jenkins X can do many more things, but this Jenkins X is
Because
CI/CD, but this is not complete CI/CD. It is just
no. Yeah. See.
delivery part is
Yellow.
handled by Argo.
The component that we are speaking about, I think it's not fair to compare these two, because Jenkins is specific to some different kind of workload, and Argo is meant for a completely different kind of workload. And that is why I think Jenkins cannot replace what Argo is doing. Maybe they can add this functionality later on if required, like Jenkins Jenkins ML or something like that. But the native Jenkins completely different.
Okay. Mm-hmm.
That's what I understand, right?
Okay. Yeah.
Okay, guys. So I think it was a great session, even though there were some hiccups from my side. Sorry for that. But trust me, if this were a live session, it would have been a lot more fun.
Of course.
Yeah. Thanks, Arjun, for this. For letting me do this.
No problem. I appreciate both of the teams coming forward and participating on this meetup. Wonderful topics to touch upon. It was nice and diverse. We had today something from the application spectrum and from the data spectrum. Going forward, yeah, we try to do this format of like 2 sessions of an hour each on Saturdays and call it like Saturday noon lives of the meetup.
Mhm.
And I'll
Yeah.
try my best to organize more in the coming Saturdays. And yeah, other than if there's any feedback on the topics that were discussed, feel free to kind of shoot it up in the Meetup group discussion board, or we have a Slack channel. The link to the Slack channel is in the Meetup group. Um, your experiences on this streaming platform. We used Jitsi, the managed version of Jitsi. So yeah, I appreciate all feedback to make the virtual meetups going forward better.
Yeah.
Uh, yeah, so that being said, thank you everybody. Thank you again for joining in.
Thanks, guys. Thanks. Finally, I think we were discussing regarding this since a long time, right, Arjun?
Ah,
We
yes,
started to discuss, I think maybe back in September, if I'm not wrong,
correct.
last year.
I need to find one more organizer. Laziness is part of my DNA, so yeah, yeah. It was nothing but I got a little bit laid back and lazy, but and things got caught up towards the end of the year.
No issues.
But
So
yeah,
what I'm so guys, just a quick one. I'm also going to organize a couple of such sessions
I
here in Europe. So I'll let you guys know. Maybe we can
perfect.
collab on
Perfect.
top of that. Not soon because I'm also settling, but yeah, in the next coming in the next quarter, Q2. So I'll ping you guys. Follow me on
Perfect.
LinkedIn.
Sure, will do. Will
Cool,
do.
man. Bye, guys. I'm leaving now.
Right?
I have a meeting.
Yeah.
So
Yeah.
see
Right.
you. Have fun.
See you. Thank you, Yusuf. Thank you, Rushil, Yalo,
Thanks,
and
Yusuf.
everybody else. I think Marcel dropped out. Yeah, but yeah, thanks. Convey regards to
Bye.
her.
Cool. Awesome,
All right.
guys. Bye. Have a great weekend.
Bye bye.